Hi, this is Detective York, and today we have been assigned to get to the bottom of this case, and we're provided these slips of paper and asked to solve the mystery of what types of mutations these are. Before we can identify the types of mutations, we must first identify the reading frame of the DNA and determine which strand is the coding strand and which strand is the DNA strand, so that we can find the original mRNA sequence resulting in the 5-amino acid protein. We know that we first must find the start codon, which is AUG in mRNA, but ATG in DNA, and read in the 5' to 3' direction. After looking at the evidence, we have found two possible breakthroughs, one in the top strand and one in the bottom strand. We have flipped the bottom strand so that we can read it in the 5' 3' direction and look more closely to see which strand is the coding strand with the appropriate reading frame. We know that it has to be 5 amino acids long, and so we need to look for the possible DNA coding for stop codons. To do this, we need to identify either TAA, TAG, or TGA. We have found these in both strands, however the top strand would be 4 amino acids long, but the bottom strand is 5 amino acids long, meaning it contains the reading frame and is the coding strand. Since we now have the coding strand of DNA, we can use our handy-dandy transcriptionator 311, which will convert the strand of DNA into the mRNA strand. Then we can analyze the mRNA strand and identify the codon sequences. After identifying these sequences, we can refer to our translation key and convert this mRNA strand into the amino acid chain as it appears on the screen. Now that we have the mRNA sequence and protein sequence from the original DNA sequence formed in vivo, we can finally take a look at these mutation evidence. Evident that these are mutated DNA sequences as they contain T's instead of U's. We need to convert them into mRNA sequences to identify the mutations and their effects. After running them through the transcriptionator 311, the following corresponding mRNA sequences popped out. I have gone ahead and done the dirty work of analyzing and comparing each of these mutated sequences with the original sequences. I have gone ahead and highlighted the reading frames and the exact point mutations, and I have also highlighted the individual codons and included the protein sequence. Looking at this first set of sequences, we can identify a missense mutation. A missense mutation is when the change of a single base pair causes the substitution of a different amino acid in the resulting protein, which may have no effect or may render the protein non-functional. This is a missense mutation as the mutated sequence codes for the amino acid threonine instead of arginine, thus substituting a different amino acid in the protein. The specific mutation is a transversion mutation, as the cytosine, which is a pyrimidine, has been changed to a guanine, which is a purine. Looking at the second set of sequences, we can identify a nonsense mutation. A nonsense mutation is the substitution of a base pair that causes a stop codon where there previously was a codon specifying an amino acid, and this premature stop codon results in a shortened, most likely non-functional protein. This is a nonsense mutation as the mutated sequence causes a stop codon prematurely where it should code for a lysine, thus resulting in premature termination. The specific point mutation is a transversion mutation, as the adenine base, which is a purine, is replaced by a thymine base, which is a pyrimidine. Looking at the third set of sequences, we can identify a silent mutation. A silent mutation occurs when the altered base pair of the codon still allows the codon to correspond with the same original amino acid, thus not having any visible effect. This is a silent mutation because both the mutated sequence and the original sequences code for valine, and thus the point mutation has no visible effect. The specific point mutation is a transition mutation, as thymine and cytosine are both pyrimidines. Looking at the fourth set of sequences, we identified a read-through mutation. The read-through mutation occurs when a point mutation has caused a stop sequence codon to encode for an amino acid, thus continuing transcription and translation beyond where it should stop. This is a read-through mutation as the point mutation codes for serine instead of the stop codon, thus allowing translation and transcription to continue past the stopping point. The specific point mutation is a transversion mutation, as adenine is a purine and cytosine is a pyrimidine. We did it. We solved the case and determined that we had a missense mutation, nonsense mutation, silent mutation, and read-through mutation. It was quite easy for us to solve since we are students in genetics 311, but for others it may not be as easy.